Did you know that there's in the sun corona? Well, the sun's corona, the outermost atmosphere of the star, is hundreds of times hotter than its surface, reaching a temperature of millions of degrees. To put it another way, something must be heating the material between the surface and the outermost layers. There are certain corona particles that gain enough speed as a result of this process to escape into the solar system in the form of solar wind. Solar scientists have studied these mysteries for more than 50 years, but they have yet to come up with a definitive answer. To find out what these answers are, NASA has sent a probe called the Parker Solar Probe. But Parker Solar isn't just going to find answers to these questions, it's more than that. So, are you excited to know more about it? Then, switch this video to full screen and watch this video till the end. Hello everyone, welcome back to the Tech Universe. Before starting, don't forget to hit the like button and subscribe to our channel to get more updates on the space and tech world. That being said, let's begin. In the past 2 decades, engineers have not been able to build spacecraft capable of studying the corona up close due to the extreme conditions surrounding the sun. But through the Parker Solar Probe, NASA utilizes the advances in modern technology to protect sensitive scientific instruments from the high temperature and radiation of the corona in order to study its particles and electromagnetic fields very closely. The probe is the first NASA project with the name of a living scientist, solar physicist Eugene Parker, who coined the term solar wind. It was announced on August 12, 2018 that the Parker Solar Probe would be launched as part of NASA's Solar Observation Program. The spacecraft is equipped with a heat shield and a cooling system in order to prevent instruments from overheating in the extremely hot corona. And among those instruments is the Solar Probe Cup SPC, which extends past the heat shield and captures electrically charged particles from the plasma in the corona, electrons, protons, and the beryllium nuclei that are known as alpha particles that make up the largest fraction of solar wind. In addition to the 2 solar probe analyzers, the SPC is one of 3 sensors in the SWEEP instrument suite. And with the help of a transparent grid and collection plate, the SPC device is known as a Faraday cup, which sorts ions by energy. Both span A and span B detectors sort particles coming from different directions in the same way, with span B examining exclusively the electrons in the plasma. By counting these particles and measuring their temperature and density, SWEEP is able to determine how the solar wind is formed. In terms of construction, the CFAE and the University of California, Berkeley were responsible for the majority of the work on SPC. There are many other collaborators on the SWEEP project, including the University of Michigan, NASA's Marshall Space Flight Center, University of Alabama Huntsville, NASA's Goddard Space Flight Center, Los Alamos National Laboratory, University of New Hampshire, University of Iowa, Johns Hopkins Department of Applied Physics, Draper Labs, and the Massachusetts Institute of Technology. Furthermore, the Parker Solar Probe carries 5 detectors, as well as the fields detector that uses 5 antennas to measure the electric and magnetic fields in the solar corona. The wide-field imager for Parker Solar Probe WHISPER, which takes images of the corona in order to reconstruct its 3-dimensional structure. And the integrated science investigation of the Sun ISIS, which uses particle detectors in order to study the behavior of very high-energy particles in the sun. This probe has been built and extensively tested in order to withstand the intense temperatures and radiation found in the corona. With such good preparations for the Parker Solar Probe, it is designed to last for 7 years and make 24 independent passes through the corona, flying by Venus to utilize its gravity and get closer to the sun as the mission progresses. In fact, it already holds the record for being the closest object to the sun. On 4 April 2019, it passed the surface of the sun at a distance of around 24 million kilometers, and this distance will only increase by 24 million kilometers during the 24 close encounters it is expected to have with the sun. And during its final 3 orbits, the Parker Solar Probe will travel within 6.2 million kilometers of the solar surface, the closest they will ever come to the surface of the sun. And this means they will face heat and radiation like no spacecraft before them. However, you probably want to know what this solar wind is all about. Well, as mentioned earlier, the Parker Solar Probe is equipped with instruments to sample the sun's corona and is targeting the region of space where the coronal plasma separates to become the solar wind. And this will give the scientists ground truth about the conditions of the plasma in that region and help pinpoint how it is accelerated outwards towards the planets. It should be noted, however, that not a single camera on the Parker Solar Probe can be used to view the sun directly, because the current technology is not capable of looking at the sun from that close of a distance and surviving. And this is where Solar Orbiter comes in. As well as accomplishing its own research goals, Solar Orbiter will provide context to Parker's solar probe that will help improve the understanding of the in situ observations made by Parker's solar probe. By collaborating in this way, the two spacecraft will be able to collect complementary data sets, which will allow for greater scientific discoveries to be drawn from the two missions than either could accomplish by itself. It is obvious that the Sun is essential for life on Earth to exist, and at the same time, it is both the central engine of the solar system and its central enigma as well. And at the end of the Solar Orbiter mission of the European Space Agency, we will have learned more about the Sun and how to mitigate the risks of it disrupting our technology on Earth than we ever have before. But the question is, how close can Parker go to the Sun? Well, with a thermal shield made of carbon composite material, the Parker Solar Probe can withstand temperatures up to 1,377 degrees Celsius or 2,500 degrees Fahrenheit, making it the closest spacecraft to the Sun. The shield cuts into the Sun's heat like a racing car into the air. When a racing car cuts through the air, the wind resistance is lowered, making the one behind it easier to accelerate. Similarly, the thermal shield pushes the heat away, making a manageable temperature for the probe and its instruments. The spacecraft moves at colossal speed at over 500,000 kilometers per hour. The strategy is to get in quick and get out quick, making measurements of the solar environment. Although Parker was exposed to intense heat and radiation, he gained valuable insights into the Sun's workings while he was on the surface. Nicola Fox, the director of NASA's Heliophysics Science Division, said, "Just as landing on the Moon allowed scientists to understand how it was formed, touching the Sun is a gigantic stride for humanity to help us uncover critical information about our closest star and its influence on the solar system." She added, "The Parker Solar Probe is one of the most audacious missions ever mounted by the agency." On 28 April of last year, Parker crossed what is considered to be the Ulfen critical boundary. This is what we call the outer edge of the corona. There is a point in space where solar material that is normally bound to the Sun by gravity and magnetic forces breaks free to flow through space. Parker crossed the boundary at about 13 million kilometers above the visible surface of the Sun. According to Stuart Bale from the University of California, Berkeley, according to data collected by the probe passed above and below the boundary 3 times in the course of 5 hours. He said, "We saw the conditions change completely. Inside the corona, the Sun's magnetic field grew much stronger, and it dominated the movement of the particles there. So the spacecraft was surrounded by material that was truly in contact with the Sun." Scientists are fascinated by the corona because it is where a number of processes take place that have yet to be explained that are presently inexplicable. The Parker science team will continue to gather more and more data as the probe probes deeper and deeper into the stellar corona during its future flybys of the Sun. It should eventually get to within 7 million kilometers of the photosphere in 2025. Parker's insights, as well as those that come from other solar observatories, have direct relevance for every person on Earth. It has been proven that the biggest outburst from the Sun can shake the magnetic field of our planet. In the process, communications may be disrupted, satellites can be knocked offline, and power grids will be vulnerable to electrical surges. Researchers try to forecast these storms, and Parker promises new and valuable information to assist them. Anyway, what do you guys think about this probe? Tell us in the comments. And that's it for the day, guys. We'll see you in the next one. Until then, peace